Welcome to 10.2, Law of Cosine and Sine. So today is going to all be about law of sines. So the big thing about this is that in any triangle, the ratio of a sine of an angle to the length of its opposite side is constant. So we follow this formula right here, that if I did sine of angle A, so sine of this angle, divided by the side length opposite of it, it's going to equal the sine of angle B over the side opposite of it. And it also is going to equal sine of angle C divided by the side across from it. Okay, it doesn't matter if the sine is on top or if the side is on top. So that's why it's showing that these two forms right here are equivalent. So however you want to write it, it will not matter in the end, depending on what way it speaks to you. So let's do a couple examples, and then you should feel pretty good on law of sines. So for example number 1, it wants us to find the side length x. Well, luckily we have law of sines. So if I look at 30 degrees, the side opposite of it is 20 centimeters. So I can write sine of 30 degrees over 20, right? That's following sine of A over the side length, is going to equal sine of 135 over x. So it's going to equal sine of 135 degrees over x. Notice I have all the sines on top and all the side lengths on the bottom. Now you have this nice proportion that you can cross multiply. So when you do so, you get x sine of 30 degrees equals 20 sine of 135 degrees. To get x by itself, we're going to divide both sides by sine of 30 because it is being multiplied. So x is going to equal 20 sine of 135 all over sine of 30. Okay, well luckily we can find the exact answer and the approximate answer. Exact, remember, is leaving pi, square root, anything like that. And the approximate is just typing into your calculator. Well, we know that sine of, we have 20. Sine of 135, once you do your unit circle 4-step process, is actually root 2 over 2. And then you know sine of 30 is 1/2. So if we asked for the approximate answer, you would give us, put right here, once you simplify this, it would become 20 root 2 centimeters squared. And if we asked for the approximate, you could give the decimal, which is about 28.28 centimeters squared. Okay, so it's really not that difficult. Just make sure when you set up your proportion, there's only one unknown, and you have all the signs either on top or all the signs on the bottom. Okay, let's do another one. So find the side length y. So I'm going to notice what I have. I know right away I have 75 degrees and 10.2. So those are opposites of each other. So I know I'm going to use that. So I'm going to start with sine of 75 over 10.2. Now I want to find y, but looking at this, you should notice that we don't know the angle across from y. Similarly, we know 62 degrees, but we don't know the side opposite of 62 degrees. So what we're going to first do is find one of these unknowns. Is it possible to find this side length? I mean, I guess we could. We could do this ratio of sine of 75 over 10.2 equals sine of 62 over x, but that still doesn't help me find y. So instead, I'm not going to find this. It's not needed. Instead, I am going to find this angle here. And that's pretty easy because a triangle sums to 180. So all I need to do is 180 degrees minus 75 degrees minus 62 degrees. This tells me that this angle across from y is 43 degrees. Now I can continue my ratio because I'm given here, this is now 43 and across from it is y. So just like before, it's going to equal sine of 43 degrees over y. Okay, so take a quick moment, solve for y, and then we can check it together. Okay, hopefully you got your answer. With it being sine of 75 and sine of 43, there's no way to give an exact answer because they're not perfect angles on a unit circle. So you would cross multiply. Y sine of 75 can equal 10.2 sine of 43 degrees. In the end, divide by sine of 75 because it's being multiplied by y. So y should be about 7.2 inches. Okay. Again, nothing too difficult. Just make sure you find the side opposite and the angle opposite. Okay, last problem here. In triangle ABC, we are given angle C is 45 degrees, B is 4 root 2 feet, and C is 8 feet. Solve the triangle, that is, determine the remaining sides and angles. Okay, so I'm going to start off by drawing this picture. I'm going to make it like this. Doesn't matter kind of what shape. I wasn't given many angles. But I'm going to call this A, or we can read it. This is A, this will be B, this will be C. I know angle C is 45 degrees. I know baby b, lowercase b, is across from angle B. So this becomes 4 root 2 feet. And then C, which is across from angle C, is 8 feet. Okay, so we need to find little a, I'm going to put it in red, that side length. We need to find angle A, and we need to find angle B. So I'm just putting in red so I know what I need to find. Now, what is great is that we have right here 45 degrees and 8. That's opposite of each other. We also have 4 root 2, which is opposite of angle B. So, law of cosine falls into place here as well. So I'm going to start with, this time I'm going to switch it up. I'm going to put the side lengths on top. So it's 8 over sine of 45. And I can do this as long as I keep the other side length on top, which would be 4 root 2 over, I'm just going to call it sine of B. I'm just solving for that. That's my one unknown. And that could be in green if you wanted to keep the colors. Okay, so let's do the math here. When you cross multiply, you get 8 sine of B equals 4 root 2 sine of 45. I'm going to do a little simplifying here, just because I know that sine of 45 is 1 over root 2. The reason why I'm leaving it in with the square root in the denominator is because you should see that these will cancel, and it actually would be a couple more steps if I decided to rationalize that denominator. It wouldn't be incorrect. It would be the same same answer, but a little different in your work. So 8 sine of b just equals 4 now. It's pretty nice. Sine of b would equal, divide by 8, 1/2. Now we've done this before, but we now want to get angle b by itself. So to undo sine, you're going to use inverse sine. So sine inverse to one side. What you do to one side, I'm just going to clean this up, move it out a little bit. You have to sine inverse the other side. And these are actually pretty simple on your calculator. Once you find that, you notice that these will cancel. And on the left side, you're just left with angle B, which is what we've been trying to find. So sine inverse of 1/2 is 30 degrees. You also can think of it as, okay, what is the angle that gives a sine ratio of 1/2? And now there's angle B. So we now have angle C, angle B. We can easily find angle A because a triangle adds up to 180. So angle A is going to equal 180 degrees minus angle C minus our angle B. So angle A is actually 105 degrees. Okay, so we're almost done. All we have left is finding side length A. Well, for this one, again, I'm going to use law of cosine. It does not matter what ratio you use now. You could use angle C compared to 8 or angle B compared to 4√2. Just because I really don't like square roots that much, I'm not going to use angle B. I'm going to instead use my 8 over sine of 45. And that's now going to compare to my side length that I don't know across from the angle that I just found. Okay, so notice the puzzle. Use one piece into the next, which is super important that you take it slow, because if I messed up angle B, then angle A would be wrong, then side length A would be wrong. Okay, same as before, cross multiply. So A is going to equal 8 sine of 105 divided by sine of 45. And you can use the parentheses if you want. Sometimes I do, sometimes I don't. So I won't be that picky. So we get 8 sine of 105, or we know sine of 45 is 1/√2. So we get the exact answer to be 8√2 sine of 105 degrees. That's the exact answer. And the approximate answer, if I put it into my calculator, would be 10.9 feet. And just like that, we have solved this triangle. We now know all side lengths and all angles. Practice on your homework. Make sure you can do law of sines. Next video will be about law of cosines.